Hi, and welcome to video 2 for section 1.5. This is the second of 3 videos. In this section, we're going to learn about the quadratic formula. So in video 1, we learned about completing the square. And there was what? There was 6 steps. And what happens when you have 6 steps? There's a lot of chance that you make a little error, and then what happens? You get the wrong answer. So a mathematician figured out this quadratic formula, and it's essentially a shortcut. So when we have a quadratic equation that we can't factor, maybe we don't want to do completing the square with it, so one of the other option is a quadratic formula. Now the derivation of this is in the book. And if you want to see how did they go from completing the square to quadratic formula, it's pretty interesting. So check it out. But in my opinion, it's beyond the scope of this course. So at Math 126, you're just trying to figure out how can I solve quadratic equations. If you get to higher math classes, then maybe you deal with the derivation of formulas and things like that. But the quadratic formula says the following: the solutions of the quadratic equation ax squared plus bx plus c equals 0, if a is not equal to 0, of course, are given as the following. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of this over 2 times a. So you're going to get 2 answers. Again, we have a quadratic equation, so we have an x squared, so that tells us, oh, we should have 2 answers here because of the degree of 2. And we get our 2 answers because we have this plus or minus square root. So let's look at an example. And in this formula, the a, b, and c just relates to our values here in the quadratic equation. So a is the value in front of x squared, b is the value in front of x, c is our constant term. So if we want to solve 3x squared minus 5x minus 1 equals 0. So you can see that if we had to do this by completing the square, it would get messy, right? Because our a is not 1, our a is 3, which means I'd have to divide everything by 3. Now I have fractions, now I'm squaring fractions, and it starts to get pretty messy. So on your exam, you might be instructed, solve this by completing the square, or solve this, or it might just say solve this equation, in which case you can use whatever option you want. And so in that case, maybe use quadratic equation. In terms of cheat sheet, I would have this on your cheat sheet. This is something you'll want to have for your reference, and probably have the completing the square on there as well. Whenever I work a problem, if I'm solving it by the quadratic equation, the first thing I'm going to do is give myself a little list on the side here. What's my a, what's my b, what's my c? So that as I'm plugging it into the formula, I'm not going back and trying to figure it out. I can just look over here and say, oh, a is this, b is that, c is this. So a in this case is what? A is positive 3. B is negative 5. You have to bring the negative signs with you. And c is what? C is negative 1. So the solutions to this quadratic are what? X is equal to negative b, so negative 5, plus or minus the square root of b, negative 5 squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, which is 3. So we get what? X is equal to negative 5 is positive 5, plus or minus the square root. Negative 5 squared is 25. And then what do we have here? Negative 4 times positive 3 is negative 12, times negative 1 is positive 12. So plus 12 all over 2 times 3 is 6. So x is equal to 5 plus or minus the square root. 25 plus 12 is 37, all over 6. And in this case, we can't simplify any further. Why? Because 37 doesn't have a perfect square that gets multiplied to get that as a value. So if I could simplify the radical, I would. In this case, I can't. So that's it. So that's your answer. So you can see here in basically 1, 2, 3 steps we're done, as opposed to 6 or more steps if we had to do this by completing the square. So that's it. Pretty short video. Biggest thing, this formula, commit this to memory if you can. If you don't already have it, I know most of you come to class, you're like, oh yeah, I did that in high school. You know, I had to learn it for my SAT or ACT or ALEX or whatever. So I already know this. That's great. But that's a big thing. Have this formula, and then how do we apply it to solve a quadratic equation? Come on back and we'll do video 3, which will wrap up section 1.5.